Okay, we're starting a new unit. In this unit, we're going to be dealing with sequences and series and then probability. Hence SSP, sequences, series, and probability. The first couple of, well, first half of the unit is dealing with sequences and series. Now, if you just list out numbers like this, separated by commas, that's referred to as a sequence. Each number in this sequence is referred to as a term. So our first term is 2, our second term is 45, our third term is 345, our fourth term is 3, and so on. Now, if the difference between any two terms is the same, then we say it's an arithmetic sequence, and that difference is called your common difference. So here's an arithmetic sequence. You'll notice you're always going up by 4, so your difference would be positive 4. Now, sequences can go on forever like this one here, meaning they'd be infinite. Or maybe they'll stop after so many terms like what I have shown here, and that would be referred to as a finite sequence. So looking down below here, see if you can go ahead and find the next 4 terms. If you look at the patterns here, you know you're going up by 2, going up by 2, so you're going to be going up by 2. And in this case, our difference would be positive 2. So you add 2 here, you add 2 to that one, you add 2 to that one, and you add 2 to that one, and you get your 4 terms. Over here, you notice you're going down by 3 each time. In other words, our difference would be negative 3. Go down by 3, go down by 3, go down by 3, go down by 3. So you can just follow that pattern. Now, when you're dealing with an arithmetic sequence, you're going to want to be familiar with this formula because that allows you to be able to find any term you want or the general formula. Because what we are doing back here, if you needed the 90th term, would you really want to list all these out until you got 90 terms listed and then answer the question? Probably not. So we could use a formula like this to help us find any one particular term. A1 is your first term. N is the number of terms. D is that common difference. A sub n is what you're getting out. So we want to know the nth term or the equation for that. So we know our first term, so we could plug in our first term. We know we're going up by 2, so our difference is 2. You could leave it like that. When it's saying an equation with the nth term, they want n in it. However, you could distribute through your 2, collect your like terms, and you would get this. Either one of these last two would be acceptable. So try to do the second one on your own. So you have your first term. We're going to leave n in there. Our difference is negative 3. So you need to make sure you put your negative 3 in parentheses. If you don't put negative 3 in parentheses, it looks like you're just subtracting by 3 rather than multiplying by negative 3. If you go ahead and distribute that through, collect your like terms, you would get this. So here we have some terms. It's arithmetic. There's 3 terms that are missing. The 3 terms that are missing in this arithmetic sequence are called your means. In other words, we'd have 21 missing 3 numbers, then 45. Now there's a couple ways we could do this. You could say, well, I know it's arithmetic, so to be able to go from this first term to the second term, I have to add my difference. To go from my second term to my third term, I got to add my difference again. To go from my third term to my fourth term, I got to add my difference again. And to go from my fourth term to my known term here, 45, I got to add my difference again. In other words, I'm going from 21 up to 45 and adding 4 differences. So one way you could look at that is I have 45 minus 21, and I'm dividing it into 4 parts, and I get 6. So in other words, I'm going up by 6 each time. So my first number here would be 21 plus 6. or 27. We go from 27 up to the next one, I'd have to add 6, and I get 33. You go from 33, I'd add 6 again, and I would get 39. So my three arithmetic means are 27, 33, and 39. By the way, if this one is 39 and I added 6, I would get 45. That's another way you can double check this. Now, another way you could look at this, you could say, well, I know that that's my first term, so I could go 21 plus, I don't know my difference. 45 is my fifth term, and if that's my 45 is my fifth term, 5 is this. Well, then all I'd have to do is solve that for D, so I could subtract 21 from both sides. I get 4 times D, and then all you'd have to do is divide by 4. By the way, you'll notice that that's the same as this. So you could use your A sub n is equal to A sub 1 plus n minus 1 times D formula if you wanted to. Or you could do it more intuitively like we did initially. It does not make a difference. Now we'll look at what is a series. Well, basically a series is where you take a sequence. A sequence, you're listing these with commas. A series, you're adding these together. So if it's arithmetic going up or down by the same number each time and you're adding, it's then an arithmetic series. Now, the formulas for arithmetic series are this. Your first term plus your last term, all in parentheses, times the number of terms divided by 2. Or if you were to go ahead and replace this here with this formula from your arithmetic sequence, if you took this and plugged it in right here and collected your like terms, you would get the bottom one. So it doesn't make a difference. A1 is still your first term, n's the number of terms, A sub n is your last term, and D is your difference. So down below here we have a couple of problems that we're going to want to use these formulas on. We want to find the sum of the first 20 even numbers, beginning with 2. Well, first of all, I would actually write out my series. First even number, then it's a series, so I got to go plus, not a comma. My next even number, plus, my next even number, and so on. And then I would go dot, 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 till I got to my 20th one, which would be 40. I'm not going up to 20. It wants the first 20 even numbers. So I get to go all the way to 20 or 40 before I get 20 even numbers. So now I have 20 terms I'm adding together, so I know n is 20. A1 is my first term, which I know is 2 from writing this out. My last term I know then is 40. Now, if I hadn't written this out, it would have been a lot harder to see that my first term and my last term and what they were. All I'd have to do now is plug that into my calculator or work it out in my head, would not make a difference, and I get 420. I'd want to do the same type of thing over here. I'd want to write out my series, the first 15 counting numbers. So that's 1, the next one is 2, the next one's 3. And because I'm looking for the sum, I need to have plus signs in here until I got to my 15th counting number, which would be 15. So n is the number of terms. Well, that would be 15. My first term, which is in this case is 1, plus my last term, which is also 15. Do that in your head or with a calculator would not make a difference. So here we need to find the first 3 terms. Now occasionally when you're dealing with a series, and it says series right here, occasionally you need to also deal with your sequence formula. Not always, but sometimes, because you're not given enough information, so you got to use the red formula before you can use this one here. Now, based on what you're given, you are given your first term, your last term, and your sum. Well, my first term and last term for the red won't help me because I don't know number of terms and I don't know my difference. because really if I know my first term, to get to the next one I need to know my difference. So I can't use that. I can't use this one down here because once again I don't know n and I don't know this. But I do know my last term, I do know my first term, and I do know this. So I could use this top equation to help me find n. Now, n's not going to help me initially get to d, but indirectly it's going to help. So I'll plug in my sum, plug in n for n. My first term I said was 14. You can see that up there. And my last term's 29. Now all I have to do is solve that. I can add these two together, get 43. Then I could divide by 43, and then I'd have to multiply by 2 to get n by itself. And I get n to be 6. So now that I have what n is, I still need to find my difference. I do know a sub n from right here. I do know my first term from right here. And I just figured out what n is right here. That would allow me to go ahead and find out what d is. And I need to know what d is so that I can actually start listing my terms. So I'm going to use that, plug in my last term, 29, plug in my first term, 14. You see those up here. Plug in n being 6. We just figured that out here. Now all I have to do is solve it for n. So I could subtract 14 from both sides. That simplifies down to 5 times d. Then I could go ahead and divide by 5, and I get my difference to be 3. So instead of going back up here, I put down the first term here. If my difference is 3, I know the next term I just have to add 3 to get to that, and add 3 again to get to this. Now it said the first 3 terms it asked you to find, not the next 3, the first 3. So I got to start with my first term being 14, then add 3 under that, and then add 3 under that. If it said find the next 3 terms, then it'd be 17 plus 20 plus 23. So on this one over here, see if you can work this one out, because it's very similar. You're given your first term, you're trying to find your next 3 terms, you know your last term, and you know your series. So you're going to use this, plug in your sum of 105. You can see that there on the right. We don't know n. You know your first term is 11. You know your last term's 31. All you have to do is solve that for n. And by the way, 42 divided by 2 is 21. And then divide by 21 and we get 5. Then we could come back and use this top center one to help us find our difference. So we'll take our last term, which we know is 31 up here. Plug in our first term, which we know is 11. Plug in n, which we just figured out to be 5. And then we can figure out what d is. So we get 4d here to get rid of this 11, and we can subtract an 11 from both sides. To get rid of times by 4, we can go ahead and divide by 5. Now we know we started out with 11, so we'll start out with 11, then we'll go plus, and then because it's arithmetic, we're adding 5 each time, so we're going to get a 16, and then we're adding, and we get 21. We know we're putting plus signs in here instead of commas because we're dealing with a series. Series is what you get when you add. If it was arithmetic sequence, then we'd have commas instead of plus signs. One other thing is we need to look at sigma notation. This funny looking E is the Greek letter sigma. It stands for sum. B on the bottom is the first number you plug in to get your first number in your series. C would be the last number you'd plug in. So on a problem like this, and by the way, what's on the right is the rule. So you're going to take 1 and plug it in here, 3 times 1. That's how we get 3. Then you're going to go plus. The next number up from 1 is 2 when you're looking at your counting numbers, and that's what we're looking at. Take 2 and plug it in. That's where the 6 comes from. The next number you plug in, would be 3. Take 3, plug it in, that's where the 9 comes from. And then you plug in 4. Plug 4 in, you do this. And then you keep doing that until you plug in this top number. Once you plug in 10, then you stop, and 10 times 3 is 30. So this is your expanded form. This is the sigma form, the summation form. So if you were asked to evaluate this, well, first of all, I would write this out to begin with. Take 3, plug it in. Take the next number up from 3, plug it in. Next number up from 3 is 4. Plug in 4, and that's where the 9 comes from. Plug in the next number up from 4, and that's 5. Plug in 5, and you get this. And I would keep doing that until I plugged in the top number. If I plug in 10, I get 21. So now, if you write it out, which I highly encourage you to do, you can see that you have your first term. You can see that you're going up by 2, so that D is 2. And then you can see that your last term is 21. Now, we need to know our first term and our last term to use our formula. We also need to know the number of terms. Now, if we had started out with k being 1 and went to 10, we'd plug in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'd have n being 10. We'd have 10 terms here. But we started out at 3. In other words, we didn't plug in 1, we didn't plug in 2, so we're missing the first 2 terms here. So if we started out with 1, we'd have 10 terms. But over here, we are missing the first 2. If we had 10 and we're not using 2, that means n would then be 8. So now all we'd have to do is plug stuff into that. Number of terms, first term, last term, plug it into our calculator or do it in our head, and we would get this.